Hey guys, how's it going? In this video, I'm going to walk through Leetcode number 230. Find the kth smallest element in the binary search tree. So let's dive in by looking at some example over here. Let's look at the binary search tree over here. And the k is 1. So we need to find the first smallest number, which is 1, right? And the second example over here, which we need to find the third smallest number, which is right here. And then we also have some constraint over here, and this question was asked by Uber for 17 times in the past 6 months. Okay, and so for a binary search tree, a property of a binary search tree would be anything on the left will be smaller than the current node. So for example, 1 and 2 are smaller than the node. Let's say the current node is 3, right? So everything on the left is smaller than 3, and everything on the right is bigger than 3, right? So same idea for the root node, right? So everything on the left is 1, 2, 3, 4. This is all the nodes on the left is smaller than 5, and everything on the right is bigger than 5, right? So so this is the property, and if we use a in order traversal, and the number will be sorted, right? So the in order traversal will be everything on the left first, and then the node itself, and everything on the right. So for example, 1. So let's do a traverse together on a piece of paper, right? So 1, and then 2, and then go to the current node, right? So which is 3, and then 4. So and then we finish the left branch, right? And then the root node is 5, right? So it's 1, 2, 3, 4, and then the root node, and then move to the right hand side, 6, right? So let's see how we can traverse the tree iteratively using a in-order traversal. The code is right here. And first we have a stack that keep track of all the nodes on the left. Okay, and also with the ith number, because we have to we only need the kth smallest. That's why the ith is keep track of the the current smallest number. And also we have the current pointer, right? So the initially the current pointer points to the root node. So while the current pointer is not none, or there are some nodes in the stack, and then what we do is to grab the leftmost, all the left nodes, but by using this while loop. Okay, so for example, for this example over here, the root node is 5, and then we keep going to the left. And while we are going to the left, we keep appending the current node to the stack. Okay, so for example, the first element in the stack is 5, and then go left, it's going to be 3, and then go left, it's going to be 2, and then go left, it's going to be 1. So for this example over here, after we finish this while loop, it's going to be 5, right? And then 3, and then 2, and then 1. Okay, and then the 1 is going to be the leftmost node. And of course, while we get out from this while loop, it's going to be a none, right? And then we pop it out, right? We pop out the leftmost node. So it's going to be 1, right? When we get out from this if statement over here. Okay, and then and again, so this while loop just get all the left nodes. And then here we have the terminal condition where if the ith equals to the k, and then we return the current node's value. And after that, we can move on to check the right of every node. So for example, after we finish the 1 in here, and then we go to check to the right, and then go back to the while loop. And of course, the right of the 1 is going to be none. That's why we're going to ignore that. And then we move up to the 2. So remember, in this stack, so we will handle the 1 first, right? And then we handle the 2, right? and then this is the terminal condition. So whenever we handle one node, we will increase the I by 1. Okay, when the I is equal to k, and then we will return the value of the node. Okay, and then we will check the right of the right hand side, the right node of the 2, which is done. So we're gonna move on back, we'll move on to the 3 because we pop it out one node at a time, right? So we move on to the 3, right? And in this case, it's gonna be the condition will be finished, right? The while loop will be finished when k is equal to 3. So let's say k is equal to 4. We will keep going to the right? So this 4 will be caught by this 3 node dot right, and then put it back to the while loop, right? And then when you work on whatever node is beneath it. And yeah, so this is the algorithm for a in-order traversal on a binary search tree. And again, so the binary search tree, if we use an in-order traversal, so all the number listed will be in sorted order. And let's turn around this question by asking ourselves, what happens if instead of asking kth smallest element, what happens if the question was asking kth largest element? Okay, let's take a look to see how we can change the algorithm and then to satisfy the condition. And before moving to the next follow-up question, so I'm going to submit this code and to show you that this is going to work. Okay, and here there's a question on AlgoExpert, which is very similar. Find the kth largest element, right? So exact same setup, and then this is the solution. Okay, and let's walk through it together. And very similar idea. We have a stack, we have a kernel, we have an I. Also, while a stack or the current node are not none or not empty array, so we will keep going to the right. Okay, so previously we keep going to the left because the left number always smaller than the right number, but now we need to find the largest number, so that's why we keep going to the right. Okay, and then we pop it off the rightmost number, rightmost node, which is the largest node, and this is the same idea. This is the terminal condition, and then we will work on the left node. Okay, and then we can run the code and submit it. It works just as fine. And yeah, so this is the two answers for these two very similar questions. I hope you find this helpful, and thank you so much for watching. See you next time. Bye bye.